Merlin, network magic, now in the data center. Hey everybody, my name's John Capobianco, and I've been working very hard on Merlin, and I have a very big feature release coming specifically for everyone running a Cisco Nexus, NXOS data center. And I've tested this on a Nexus 9K, 9000, 7K, 5K, and 2K FEX, or fabric extenders, which, in case you're not familiar with a Cisco data center, are like top-of-row switches that don't have a local management or control plane. They're like remote line cards from one of the 9, 7, or 5K Nexus parent devices. So what I did is I went out and got a whiteboard to help explain what I'm doing here and what Merlin is, right? So Merlin for NXOS. And let's try to look at the 4 major things that we're going to do with Merlin. And this is a high-level overview, and I'm going to do a deeper dive into each of these things in subsequent videos. But just to give you a sense on what Merlin is and what I'm trying to accomplish here. So first, we have to connect to devices. And if I could quickly mock up, so what I'm going to be connecting to, I have a mock disaster recovery data center, and it has 2 Nexus 9Ks, and these are attached to some 2K FEXs. I don't know how many, but these scale, right? Now, I have interswitch links here, and we're running HSRP here because it's a data center. We want that redundancy protocol there for our first hop. And these are port channels to the FEXs. And we don't need to get into the nitty-gritty here, right? That's really all I care about. I have a data center with a pair of Nexus 9000s and some FEXs. Now, in my other data center, I have a bit of a different topology. This is a very collapsed aggregation access layer, right? And it would uplink to a core northbound here. But it's a collapsed data center. Whereas in my other data center, I have more of a traditional 7K, right, with interswitch links here that connect to 5Ks, right, and some interswitch links here. That would be a port channel. That would be a port channel. And then our FEXs, 2K FEX, right? And, south of this is our stuff. Storage area networks, bare metal servers, Windows servers, VMware hosts, whatever's connected downstream in the data center. So, right, first we have to connect securely to these devices. And then the first thing that I'm going to use and leverage is the learn feature from the PyATS framework using the Genie software development kit. So think in your mind of like a Pythonic way of calling this would be device.learn. And what can we learn? Well, we'll explore that in a second, but we can learn features. We can learn protocols. We can learn interfaces. We can learn the full config. And we can learn about the platform and other things like ACLs. We'll see. I think it's 11 learned features that we're going to do for each of these devices. Right, so 6 devices in 2 disparate data centers, but they're running the same operating system. So then beyond learn, we're going to parse. And parse is our show commands, our traditional show IP interface brief. And I don't know how many of these we'll have. We'll check. I think it's about 30. I don't know. We'll check. We'll double check. That might be a bit high. 25. There's a lot of them, and I haven't finished them all yet, but I have a good collection of them started. Okay, so we have learned and we've parsed data. Well, what does that mean for us? Well, it means that as of this step in the Python, in the Merlin job, we have JSON, JavaScript object notation. Okay, now this JSON, we want to then document. And what do we do? What do we want to document? Well, let me just quickly make some space here. So again, that green wasn't very good. Let's try the blue. We have JSON. Blue's no better. Can't really see that. Let me just switch to the black. We have JSON, JavaScript object notation. So that's one of our documents. I'm just going to take the JSON version of the learned feature function interface whatever, or the show command, and just save that to a file. Then from that JSON, this is where the Jinja 2 templates come in, and we pass that JSON through the Jinja 2 to come up with a CSV, a spreadsheet, a markdown, an MD file, and an HTML page that we use Jinja 2 to template. Now I call those the business ready documents. Now from the markdown, I can pass that through mark map and make another HTML page, which is an interactive mind map, which is another way to represent the document, the information. Now another set of Jinja 2 documents, templates, is a separate HTML page, which is a front end for more JavaScript, not JavaScript object notation, but real JavaScript that we make the network graphs from. So a quick recap. If I can find the lids for my pens. Right? Quick recap. We're going to connect to devices in a test using what they call a test bed. And we'll look at a test bed. Then we're going to learn as much as we can. And we're going to parse as many commands as we want. Get the JavaScript object notation, the JSON. And then we're going to create documentation. So when I talk about connecting, we need to use, and I have different test beds for different environments. I have a test bed specifically for NXOS. And yes, my passwords are on the screen, but I'm okay with that because they're fully encrypted as secret strings. Okay, so I could encrypt any piece of information. I could encrypt the whole file. I choose in this lab environment to encrypt the password. But let's take a step back. I just wanted to highlight that you can use what they call secret strings to encrypt information in the PyATS environment. So we start with devices, and then we have the name of the device which matches the host name of the device. We have an alias, a type, the operating system, the platform, our credentials, and then the connection information such as the SSH and the IP address and some timeout information. So this is how we achieve that first step. PyATS, the framework, takes care of everything else for us. We just have to simply, and for you, a user of Merlin, if you've cloned my repository, you just punch in your credentials and your IP address, your device name, your alias, etc., and the rest of the code should be ready to go for you. Now I want to highlight that things like platform, Merlin actually uses as a key. So please make sure if you've cloned this that your test bed accurately reflects your environment, because I have logic in certain places because of the PyATS and the Genie parsers that sometimes the templates are a little bit different between a 5K and a 7K, things of that nature. So make sure that you put that information in. Now, again, I have a folder that we're going to call Camelot, and in the NXOS, we talked about learn and parse. Well, here are the 11 learned functions, protocols, features, and then look at all of these show commands that we are going to parse into business-ready documentation. And if you spot one that's missing, let's say, a command that you rely on, provided there's a parser for it, I'm happy to incorporate it into Merlin. I want this to be valuable and useful. So if you take a quick scan here and I don't know, I'm missing some command, let me know and I'll add it in a future, release. So I just wanted to get a sense. We're not going to dive into the actual output files or anything like that today, but this was just an introductory video to show you Merlin and the capabilities. So if we go to the README file of Merlin, I would start here, and it's like any other README file. You can jump right in and clone it and try to use it, but there is some valuable information here. It has been published on Cisco DevNet Automation Exchange. And again, it's simply a better way, a magical way to collect, transform, and configure network state information from the CLI or the REST API. This particular release, NXOS, is a CLI automation tool, so you don't even need to have the REST API enabled. Again, it builds on the Genie Python test automation software development kit. It uses the PyATS framework, and then we have the MarkMap, the NetJSON, and a TinyDB, which I didn't mention earlier, but when we also document, one of the documents is a database that we can query or use as consume as a database from other applications. So here's an idea again of those learned features. And some of them, such as STP and LLDP, they don't work on the NXOS platform. So I've put a lot of work into this, and I've given my feedback upstream to the developers. And of course, we would love to have learn State Banning Tree Protocol in the Nexus world and learn LLDP, or even more learning. So they're just steadily pumping out the releases. But again, what do we get? We get the nice JSON file, a nice YAML file, a CSV spreadsheet, a markdown file, an HTML page, an interactive mind map, an interactive NetJSON network graph, and a TinyDB. So I'm going to leave it there today for this little video. And again, all of the stuff you need is in the README here. And I'm available on Twitter or anywhere else if you need to reach out and have some assistance. And I'm going to make a series of focused videos. There might be a lot of them coming because of all of the commands that I'm doing. But let's explore the data center and let's look at it in a new way, a programmatic way, using the key file as the JavaScript object notation. And believe me, OSPF, multi-VRFs, BGP, the data center is another level of complexity. Even the HSRP and having that redundancy protocol. There's things that you may not encounter in the enterprise world that you're going to have to deal with in the data center. And we're going to make it a lot easier to consume as an easy searchable, sortable CSV file. And I've looked at some of this output and it's really incredible. So look for the focused video series. They're going to be, one at a time. We're going to go through everything and I'm going to try to show how it's done. We're going to do code deep dives. We're going to look at the different output formats. And if you have any questions, reach out to me. It's John_Capobianco on Twitter. And automateyournetwork.ca is my homepage. So we'll see you soon and get ready for the big Merlin NXOS release.